For decades, many decades, scientists have been using a circular dichroism spectroscopy for looking at the chirality of molecules. Circularly polarized luminescence is the emission analog to CD, and it's been much slower to be adapted than CD, partially or perhaps significantly because of artifacts which lead to the incorrect answer being calculated. And this is because CPL is an extremely tiny signal, and it is often contaminated by linearly polarized signals. So this section in Feldman's 2023 Advanced Methods paper discusses artifacts due to linear polarization components of the emission. So this is not the sample. This is actually the instrument itself, which contributes some of the LPL. Additionally, the small yet significant static birefringence of the PEM itself can convert the linearly polarized light into CPL artifacts. In summary, a linear component in emission affects gLUM via both the AC and the DC values. Importantly, the sign and magnitude of these artifacts are very sensitive to small realignments of the sample or the setup. Hence, a baseline correction is not suited to resolve this problem. In general, it is possible to derive analytical expressions for the effects of linear polarization artifacts on the CPL signal. However, this approach requires knowledge about the polarization responses of all the optics used and a thorough Stokes-Mueller matrix analysis of the setup. Measuring CPL spectra at different angles of rotation of the sample around the excitation light propagation axis can give an estimate of the magnitude of the artifacts. Also, a quantitative mirror image relationship between CPL spectra of enantiomeric materials may indicate that the influence of artifacts is small, but generally, without elaborate corrections, CPL signals that arise while there is a linearly polarized component should not be trusted. So obviously reading this kind of puts the fear of God in the manufacturers of CPLs as well as researchers who choose to use this technology. So you can imagine how extraordinary it is for us to be able to announce that we have a means of mathematically separating the contaminating linearly polarized light from the answer of interest, which is the circularly polarized luminescence. And we do this utilizing a direct digital acquisition method without a lock-in amplifier that combines these signals, and then processing these separated signals with FFT, separating them with FFT. And so in this way, we have clean LPL, we have clean CPL, and therefore we can calculate gLUM using only the circularly polarized luminescence. And then for fun, you can combine the two and see what you're getting with other technology instruments. Not the right answer. So anyway, if this is something of interest to you and you'd like to further the conversation, I would love to hear from you. So please be in touch.